Hey, wake up. Why isn't your PCB conducting again? Well, about 70% of PCB conduction failures come from issues during via metallization. Welcome back to our PCB manufacturing series. Last time, we covered drilling. Today, let's look at the via metallization process. After drilling, the board first goes through electroless copper plating, then electroplating. Electroless copper is a chemical process that uses redox reactions to deposit a thin copper layer on non-conductive hole walls, usually resin and glass fiber. Why not go straight to electroplating? Because electroplating needs a conductive surface, and hole walls aren't conductive at all. So we first deposit a thin chemical copper layer, 0.3 to 1 micrometer, which makes the hole walls conductive for later electroplating. Got that? Now it's time to de-oil you. The board goes into a 50 to 60 degrees Celsius alkaline solution, pH 10 to 12, for 3 to 5 minutes. This removes oil, oxide, and dust, and also adjusts the hole wall's polarity from weakly negative to evenly positive, so it can attract palladium later. Every step in this process needs 2 or 3 stages of counterflow rinsing to avoid residue from the previous chemicals. What's counterflow rinsing? It's a multi-stage rinse where water flows opposite to the board's movement, ending with deionized water at 20 to 30 degrees Celsius and resistivity 5 mmOM. Next, micro-etching. We clean off oxides and roughen the surface so the copper layer sticks better. Etch depth is carefully controlled, 1 to 2 micrometers, to avoid weakening conductivity. Then comes pre-dipping. It prepares the board before it meets palladium, so no leftover chemicals ruin the precious palladium bath. It wets the holes and stabilizes the copper ion environment. Now, activation. We dip the board in 35 degrees Celsius palladium chloride for 2 to 4 minutes. Palladium particles, in colloid form, stick to the hole walls because of opposite charge attraction. This is critical. Underactivation equals weak plating, overactivation equals clump. Next, decolloidizing. We remove the protective tin layer to expose the palladium core, which will now catalyze the copper plating. Time for the main event, electroless copper plating. In an alkaline bath, formaldehyde reduces copper ions to metal copper. Each new layer of copper helps catalyze the next, self-sustaining. We carefully control temperature, 30 to 40 degrees Celsius, pH, 11 to 13, copper ion. 2. 5G/L, air agitation, to avoid copper powder settling and ensure oxygen for oxidation. After this, you get a 0.3 to 1 micrometer uniform chemical copper layer. Then we move on to electroplating. Using electrolysis, we thicken the copper layer on the base deposited during chemical plating. In the bath, PCB is the cathode, pure copper plates are the anode, acidic solution with copper sulfate and chloride ions. Current, 1, 3A/dm superscript 2. Temp, 20 to 30 degrees Celsius. Cu superscript 2 concentration, 25, 45 G/L, pH, 1.8 to 2.2, adjusted by sulfuric acid. Copper dissolves from the anode, moves through the solution, and deposits as metal copper on the PCB surface and hole walls, forming a 20 to 25 micrometers copper layer that meets IPC Class II standards. At NextPCB, we strictly follow these standards in production. Congratulations! You're now a fully conductive board. Next episode, we'll build your outer layers. Don't forget to like and follow. See you next time.